All right, we are moving on to a new topic today. We are going to look at sum and difference properties when we're dealing with trig functions. The sum and difference properties you have at the top of your note sheet, but you also have them here on your master formula. And I know formula sheet. I know they look a little bit scary, but hopefully you won't think that they're too bad. And I don't think they will be. But you have to use these formulas every time you use a sum and difference problem. Okay, so our first topic here, our first problem we have to do is we have to find the exact value. That means you're not going to go to your calculator and get a decimal for it. You have to find the exact value for cosine at pi over 12. So that seems kind of easy. It seems like, oh, well, you'll just go to your unit circle and I go to pi over 12, only the problem is I don't have pi over 12. Okay, so you need to have a strategy to deal with this. So first of all, I think it's easier for people to think in degrees instead of radians. So I am going to actually change this pi over 12 back to degrees so that we can think about this a little bit easier. So I'm going to multiply that, if you remember, by 180 over pi so that you can switch that. And that then becomes cosine at 15 degrees. Okay, all I've done is switch it to degrees. Still, if you look at your unit circle, I don't have 15 degrees on there. Okay, so now your strategy is to find two numbers that you do have on your unit circle that will either add or subtract to make 15. Like you wouldn't want to use 25 minus 10 because 25 minus 10 certainly is 15, but I don't have 25 degrees or 10 degrees on my unit circle. So I want to be able to use these numbers right here that can either add or subtract to make 15 degrees. And there's many, many, many options here. You could do 45 minus 30. You could do 60 minus 45. You could do 135 minus 120. You could do negative 315 plus 330. However you want to do it, it doesn't matter. It really makes no difference. I'm going to use 45 minus 30, but you can use it whichever way you want. Okay? So I'm going to take that cosine at 15 degrees, and since I don't have it on my unit circle, I'm going to rewrite that 15 degrees as 45 minus 30, which I do have on my unit circle. Okay, again, you need to pick numbers that you have on your unit circle. You can't just pick any random number. Now, I'll say this 85,000 times when we're doing this unit, but when you get to something that looks like this, what you've always done in math at this point is distributed this through. Okay, but when you're dealing with the properties of trig functions and angles, you can't distribute. Okay, that's not what you want to do. What you do want to use is your sum and difference formulas. Whenever you're adding and subtracting two angles, you need to use your sum and difference formulas. Notice this is cosine right here, and I have a minus sign in between. And so what I'm going to look for is my formula that has cosine, two quantities that are subtracted. So cosine with that minus sign in between, I'm going to use this trig property right here. And this is kind of what's happening. My alpha in my case is 45 degrees, and my beta is 30 degrees. So I'm going to use the other side of the equation, and wherever I see alpha, I'm going to put 45. And wherever I see beta, I am going to put 30. And so then I'm going to use that formula right there. Okay, so it'll turn into this. Cosine at 45, cosine at 30, plus sine at 45, sine at 30. Okay, now at this point what you're going to do is you're going to go look all of these up on your unit circle. So first of all, you're going to go to 45 degrees. Okay, so 45 degrees is right over here. I'm going to erase this and clean this up a little bit. 45 degrees is right here. Cosine, of course, is your x value. If you still need to draw the triangles, you can draw the little triangles. Your hypotenuse is 1. This would be root 2 over 2. This would be root 2 over 2. Cosine is adjacent over hypotenuse, so root 2 over 2 over 1, which is just root 2 over 2. Cosine's your x value. Sine's your y value if you have not yet figured that out. Okay, so cosine at 45 degrees, your x value right here would be root 2 over 2. Okay, then I'm going to go to 30 degrees. So I'll go to 30 degrees on my unit circle. And if I go to 30 degrees is right here. Cosine is your x value, which is root 3 over 2. So I go back here, and cosine at 30 is root 3 over 2. Okay. back to 45, and now I'm looking for my sine value. So at 45 degrees, sine is your y, which is root 2 over 2. And sine at 30 degrees, as long as I'm over here, is 1/2. Okay? So sine at 45 is root 2 over 2. Sine at 30 is 1/2. All right, then you just need to simplify this and you'll be done. Okay, here are your multiplying fractions. Root 2 times root 3 is root 6. And 2 times 2 is 4. Remember, when you're multiplying fractions, you multiply across the top, multiply across the bottom. On the other side, root 2 times 1 is root 2. And on the bottom, 2 times 2 is 4. And you can't add root 6 plus root 2 to make it be root 8. You cannot simplify that. So you're going to just need to leave this as root 6 plus root 2. But you have a common denominator, which is fabulous. So put that fraction into one denominator over 4. And just so you know, when you're checking your answers in your book, they might write it, sometimes they do this, like this, which of course means the same thing. Okay? But just so you know, they might write it like that. All right, moving on. Now we're going to go to do secant at 285 degrees. Okay? Secant at 285 degrees. Again, if you go to your unit circle, you don't have 285 degrees on there, which is kind of a bummer. So you need to think of two quantities that you do have on your unit circle that either add or subtract together to make 285 degrees. Okay, you wouldn't want to do 230 and 55 because you don't have 230 or 55 degrees on your unit circle. So you want to find ones that you do have. Many options here. I am going to choose to do secant at 240 plus 45. Okay, and you might have chosen different ones, but as long as your two numbers add or subtract together to make 285, you're good. 240 plus 45 does make 285. Okay, now I need to find secant at 245. Again, you're not going to distribute. You can't take secant times 240 plus secant at 45 and expect to get an answer. You have to use your sum and difference formulas. The problem, though, however, is that we don't have a sum and difference formula for secant. So we need to think about some things we know and use our trig proportions. Okay, we know that secant is 1 over cosine. Okay, so if I want to find secant, then I need to do 1 over this formula right here. Okay, so, and again, my alpha will be 240 in this case, and my beta will be 45. So wherever I see alpha, I'm going to use this formula right here. Where I see alpha, I'm going to put 240, and where I see beta, I'm going to put 45. Okay? So, and it's secant, and I don't have a secant formula, so I have to do 1 over the cosine formula. So, here we go. 1 over cosine at 240, cosine at 45, minus sine at 240, sine at 45. Okay, this gets just a little bit uglier, but you're going to go to your unit circle. You're going to look up cosine at 240, cosine and sine at 240, cosine and sine at 45. Okay, so I'm going to go over here. At 240 degrees, so here's 240. Your cosine value is 1/2, or negative 1/2, and your sine value is negative root 3 over 2. At 45 degrees, your cosine value is root 2, and your sine value, or root 2 over 2, and your sine value is root 2 over 2 as well. Okay? So this will be cosine and sine at 240, cosine and sine at 45. And you're going to plug those numbers into the formula that you have. Whoops, wrong way. All right. So cosine at 240 was negative 1/2. Cosine at 45 was root 2 over 2. Sine at 240 is negative root 3 over 2. And sine at 45 is root 2 over 2. Okay. So then down here, I have right here, negative root 2 over 4 minus negative root 6, which obviously turns into positive, over 4. Okay, so now I have this. I have negative root 2 plus root 6 all over my common denominator, which is 4. Okay, now, can't have double fractions. I don't want you to end up your formula with double fractions in it. So instead of dividing by this quantity right here, I am going to multiply by its reciprocal. And now I'm here. And I'm going to switch these two around just because I like my first term to be positive. So I'm going to make this be 6 minus root 2 instead of negative 2 plus root 6. It doesn't matter. You can leave it if you want, but I'm going to do that. Now this is fabulous. I'm down to one fraction, except for I have radicals in the denominator, which is not cool. Okay? Some people think, oh, we'll just multiply by root 6, which is fabulous. That gets rid of the root 6, but it doesn't get rid of the root 2. Then they go, oh, we'll multiply by root 2. Same problem. Okay? So your solution to this is to do conjugates, if you remember. The conjugate to root 6 minus root 2 is root 6 plus root 2. You just switch the sign in between there. You never switch the sign on the first number. You only switch the sign in between. That's it. Okay? And then root 6 plus root 2. All right, then I'm going to distribute across the top. So I'll have 4 root 6 plus 4 root 2. In the denominator, root 6 times root 6 is root 36, which is, of course, just 6. Over here, I would have root 12. And my inside's negative root 12. And my last, negative root 2 times negative root 2 is negative root 4, which, of course, is negative 2. Those will drop, which they always do when you do conjugates. And you will have this, 4 root 6 plus 4 root 2 all over 6 minus 2, which is 4. And then, of course, all those lovely 4's can reduce, so those can all be canceled, and you simply have root 6 plus root 2. Phew-ta. Okay, so there's that one, and I have one more for you. And this is cotangent at 19 pi over 12. And again, I don't like to think in radians. I think that's harder to think about. If you want to, you go for it. I'm going to think in terms of radians. So I am going to multiply by 180 over pi. And I will get cotangent again at 285 degrees. Okay? Lots of options for 285. I think I used 240 plus 40 last time. This time I'm going to rewrite that 315 degrees as 315, or not 315, 285 degrees as 315 minus 30. I want to do a subtraction one. Okay, 315 minus 30 also makes 285, so that is totally cool. Here's the problem. Again, do not distribute. Don't find cotangent at 315 minus cotangent at 30 and get an answer. That's not going to work. You have to use your sum and difference formulas. The problem here is you don't have a formula for cotangent. And so what you need to do is you need to do this. You need to flip tangent. Okay? Cotangent is 1 over tangent. But now I want you to think about this. I'm going to just call this whole formula right here x, the whole numerator x, and the whole denominator y. Okay? And watch what happens. If you have 1 over x over y, instead of dividing by x over y, you can multiply by y over x. And now you have 1 times y over x, which is just y over x. So here's the deal. When you're doing cotangent, cotangent is the reciprocal to tangent. Well, cotangent and tangent are reciprocals of each other. So when you do the cotangent formula, you just have to take the reciprocal to this one. Okay? So it's going to look like this instead. 1 plus tangent alpha tangent beta on the top, and tangent alpha minus tangent beta on the bottom. Again, since cotangent is the reciprocal to tangent, take tangent's formula and flip it. Okay? Now, I chose to use 315 and 30, so I will plug 315 in for alpha and 30 in for beta. So it should look like this. Okay, so now we have a little work to do to figure out tangent at 315 and tangent at 30. Okay, So tangent of 30, again, tangent at 30, if you make your handy dandy little triangle, tangent at 30 is opposite over adjacent. So your opposite is 1/2, your adjacent is root 3 over 2. And so you need to go 1/2 over root 3 over 2. Can't have a double fraction, so you flip the 2 over root 3. The 2's cancel. I'm at 1 over root 3. Can't have a radical in the denominator. Multiply by root 3, and you'll get root 3 over 3. Okay, so tangent at 30 is root 3 over 3. Now I'm going to go over here to 315. 315 is down here. Okay, and at 315, when you do opposite over adjacent, this is root 2 over 2. This is negative root 2 over 2. So opposite over adjacent would be negative root 2 over 2 over positive root 2 over 2. Don't make this any harder than it needs to be. Negative 5 over 5 is negative 1. So negative root 2 over 2 over positive root 2 over 2 is negative 1. Okay, so tangent at 315 is negative 1. All right, so now I'm going to plug those things into my formula here. Okay, tangent at 315 is negative 1. Tangent at 30 is root 3 over 3. On the bottom, I will have this. Okay, common mistake people will do is they'll take the 1 right here and the negative 1 right here, and they'll try to add them to make 0. Remember, you need to multiply before you can add and subtract, so that's not going to cut it. I actually have to take that negative 1 and multiply it by the root 3 over 3. So this is what I have. Negative 1 times root 3 over 3 obviously will create negative root 3 over 3. And then on the bottom I have this. Lots of people will look at this and go, oh, well, that's easy, it's negative 1. But the problem is the 1 right here and the negative 1 right here are opposites of each other, but these are both minuses. So the answer is not negative 1. Okay? So we have some work to do here. We need to take this 1 and get it into common denominators so that I can get this as one fraction. And same thing here, my common denominator, I need to make that be 3 over 3 so that I can get this as one fraction. And then on the top right here, I will have 3 minus root 3 over my common denominator, which is 3. And on the bottom, I'll have negative 3 minus root 3 over my common denominator, which is 3. Okay. Don't like the double fractions, so I will take this quantity right here and I will flip it. My 3's will cancel, and I'm here. Again, people will think this is negative 1, but it's not. They're not both opposites of each other. So you have a radical in the denominator. Yay, which means you need to use conjugates. Okay, so here we go. The conjugate to negative 3 minus root 3 is negative 3 plus root 3. Again, you're only going to change the sign in between. Okay, on the top, I get to FOIL this. So 3 times negative 3 is negative 9. 3 times root 3 is 3 root 3. Negative 3 times negative root 3 is positive 3 root 3. And negative root 3 times positive root 3 is negative root 9, which is negative 3. On the bottom, negative 3 times negative 3 is 9. Negative 3 times root 3 is negative 3 root 3. Negative 3 times negative 3 root 3 is positive 3 root 3. I think I said that wrong. But you know the gist. Negative root 3 times positive root 3 would be negative 3. Okay, on the top then, these two can be combined right here to make negative 12. And then these two can be combined. I have 3 root 3's and 3 more root 3's to make 6 root 3's. On the bottom, these are going to cancel, and you will have 9 minus 3, which is 6. Okay, and then everything is divisible by 6, so if I take negative 12 divided by 6, I have negative 2. 6 root 3 divided by 6 is just root 3, and 6 divided by 6 is just 1. So this is your grand final answer. Phew-ta. A lot of work there, but we did it. You're not going to have very many problems for homework when you do this. So we will talk about that when we see you.